Hello and welcome to this afternoon's session on reverse engineering products with me, David Durston. Now, we're going to be talking two sections this afternoon. First about scan to 3D. We're creating a usable model from scan data, and we're going to be covering importing meshes, creating surfaces from meshes, and then creating curves from meshes. And then after that, what we're going to be talking about is direct editing. So if you've been given an imported model, what we can do with it, and some of the things we're going to cover: split, move copy, move face, combine, delete, deform. And I just wanted to make the point that once you've got a solid, even if you don't know how that solid was made, all the other SolidWorks tools still work. So without further ado, let's get into SolidWorks. Now, you may well have opened an gone to open an STL file, and eventually it will come in and it will give you an STL graphic. Now these look lovely, but as you can hear me clicking around, you can see they don't do anything. Now what we can do is, under the SolidWorks add-ins, there's something called Scan to 3D. Now this is a SolidWorks Premium add-in, so those of you with SolidWorks Premium already have this. And if we turn that on, when we attempt to reopen this file, we will have the option to open mesh files or point cloud files. So I'm going to select mesh files and then reopen this automotive transfer case. And what this does is, rather than trying to bring it in and create a solid for you, where SolidWorks does have a limit on how big a model it can do, it's going to bring it in as the mesh. So this is the same as same sort of mesh you might see if you brought it in or if you did some simulation work. So just let that finish importing. And if I show this as hidden lines removed, we can actually see the mesh. And scroll in, you can see it, and you can see how it's coarser on the flat surfaces, and it gets more finer on the curved surfaces. Now this particular mesh file came from Measurement Solutions Limited, and they scanned it using a Creeform handy scan. And then the software they used on the other end was something called VX Elements, and this turns it straight into an STL. So from the scanner with your hand straight to an STL. So there's no messing around with creating the mesh or doing anything with the point cloud. You get straight to STL, and then the STL comes straight into SolidWorks like this. So it's nice and simple. So what we're going to do is, rather than attempt to work on this file because it's pretty large, there's sort of like 1.6 million points, we're going to work with something a little bit simpler for speed. So what I'm going to do is I'm going to choose to open again a mesh file, in this case a house brick, and let that come in. Now this is considerably simpler, as you can see, but it does enable me to show you quite a lot of the features. So the first thing you always do with the mesh is use the mesh prep wizard, and what this does is this sets the mesh up ready to do the next stages. So first of all, it allows you to select your mesh and tells you how many faces there are within the mesh. And then we've got the option to orientate the mesh if we want. So we can do it, leave it as it is, we can choose automatic, we can select references, or we can put in numeric input to define where the origin is going to be. But I'm actually quite happy where it is. We then have extraneous data removal. This enables us to take out sections that we don't want to actually include. They sort of got caught. So for example, if you were scanning on a table and you caught a bit of table, you might have a bit of table hanging over here as a bit of mesh, and this enables you to get rid of it. We then have simplification. So what this does is, if you've got, for example, a flat surface with a really fine mesh on it for some reason, then you can simplify that. So you can take out the amount that's in there. You can do this overall, or you can do it on a local area. Be aware, the simpler stuff is, the less accurate it is, particularly in curved areas. We then have global smoothness and local smoothness, and this is trying to make everything flat, which is, on the side of a house brick, brilliant if you wanted to locally smooth it. On our gear transfer case, then we've got lots of smooth transitions and changes in height. It's not so good. Global smoothness essentially tries to make everything a flat sheet. So the smoother it is, sometimes good on an area, but over a whole model can cause you some problems. And now we have the option to automatically launch Surface Wizard because we're finished with mesh prep, and we're going to go on and do that. Now you've got two options. You've got automatic and guided. In general, automatic is better for very curvy shapes, and guided creation is better for more sort of angular bodies. So in this case, the body we're going to be looking at here. So we're going to do guided first. So first of all, we have an option to split it up. So you can, for example, you can use planes to cut a section out of your model and just do the Surface Wizard on that. Or if you've got planes of symmetry like we have on the house brick, you could choose to cut it up and just fix one corner or one half and then mirror that round to get your complete body. But I'm going to keep the whole body here so we can work through it. We then allow it to paint all of the faces that it can find. And if we hit apply, we can then have a look at the submeshes in order to break that down further. You've also got the option to paint all the faces, so every face now has a different colour. You can probably just about see them on the screen there. And this is an opportunity for you to go through and actually colour in the stuff that it's got wrong. But in this case, because it's a relatively simple shape, it's managed to pick up all the faces as different faces pretty easily. And now we have the option to extract our faces. We can choose extract all faces and allow it to do everything automatically, or we can choose to click on a face and select what sort of face it is. So whether it's a planar face, a cylindrical face, a conical face, spherical face, toroidal face, an extruded surface, a revolved surface, a ruled surface, or a B-spline surface. Now, for us, all of our surfaces are actually going to end up being planar surfaces, but if I go through and select those now, so what we'll do is we'll do this, and as I select these, you can see the number of regions that have not been specified is slowly going down one at a time as I select them, and the number of faces that it actually knows about and has been extracted, it allows to go up. So just let me select through all of these. I've got 3 more, which is going to be on this side. And like I said, mine are all planar, but you can choose different types of surface each time. So now I've extracted all the faces, and you see it's happy, there's no more to go. We hit carry on, and it actually creates these surfaces for us. So we have a number of surface bodies, and we can complete that. So now I've got a number of surfaces. So those of you hoping that the direct editing would allow us to avoid using surfaces, unfortunately not. Solid modeling essentially is where the computer's worrying about turning surfaces into solids. So when we go back to the very base levels like we are here, we have to go back to a lot of surface modeling. So now I've done that, what I can actually do is come into the surface tools and I can start to trim my surfaces. So for example, we're going to do a mutual trim, and I'm going to select the 6 surfaces that make the outside cube, and I'm going to choose to keep. It helps if I select the next box. So we've got all of our surfaces there, hit the tick, and now we've created our oblong. We're going to do one more mutual trim, and this time we're going to be creating the frog of our house brick. And we are going to remove selections. In fact, that's a lie. We're going to keep selections. Let me hide my body. And we're going to do one more surface trim, but first of all, I'm just going to hide away that solid or that surface body so that I can see what I'm doing. So we're going to do a trim this time of our 4 frog ones, and we're going to keep the inner shape. So now I've got that, and if I hide my other surface body, I'm now down to 2 surface bodies and one last trim using our 2 bodies, and this time I'm going to choose remove selections, and we're going to remove that, and we've now got our brick shape. Command of thicken on a surface trim, create a solid, and we're now back to a solid model. At this point we can start to add fillets as we would do usually on a model. So we can choose to fillet, we can select the top face, the bottom face, and the 4 vertical edges. Ooh. And then all we're doing now is looking to do a radius on those, and in this case I happen to know that it's 2 mil, and we can see that that lines up with the remaining fillet faces, which don't usually get removed by creating our surface bodies. And if we hide the mesh, you can see we're now back to our solid house brick. So that's a very quick way of using guided creation in order to get from a mesh straight through to a solid, and we can now do our modeling with it. So what I'm going to do now is we're going to have a look at the other types of surface creation. So again, we're going to use mesh files, and I'm going to open this bottle. So this is a much more curvy shape, and we start Mesh Prep Wizard, and in this case I happen to know everything is okay. Again, we're going to launch the Surface Wizard automatically if I don't click the green tick. So we're going to use that surface. We're going to use automatic creation this time. We're going to leave the surface detail as it is. We can choose to update the preview, and you can sort of see some lines there, and you can see some red where it's going to have problems creating those surfaces for one reason or another. And if we choose to turn on the edit feature lines, what we can do now is you can see these orange lines are where the software is going to be dividing surfaces up. So at the moment you can see we've got a problem around the top, and we can see we've got points around this side, but we haven't got any points over here. So what I'm going to do is I'm going to add some feature lines. So what we do is we move around the model until we can see a red dot like that, and then we draw a line from one red dot to another red dot, and that adds in an additional point. So we can keep doing this. If we put one over there, and we'll join that up. Now you can see I've got this line here. In order to add a feature point, you need to go from a new point to an existing point. So now I've finished with that, I can actually delete that line. Highlight it and delete it and remove it because I don't need it anymore. Now I've got these points, what I can do is I can start to drag them around, and we're just bringing it around this side to try and even out the circle. So you see straight away my feature lines sort of representing my edge, and if we choose update preview, we can see it's now fixed the top there. We're not going to get any error surfaces. If we have a look at the bottom, we can see that this is not very symmetrical at all. So what I'm going to do is I'm going to attempt to move this point down towards the bottom edge, and we are looking for this green dot that you've got next to my mouse, which is saying it's a valid place for me to let go of it, and I'm going to put that down there. Again, I'm going to choose to update the preview, and we can see this is starting to look a lot more symmetrical. Obviously I can spend some more time building this model, but for demo purposes we're going to accept it like that. Hit next, and it says it's complete and it's vanished. Don't worry about that, it does it every time. All you need to do is hide it and re-show it, and it will reappear. So now we have a surface body, or sorry, a solid body that represents our surfaces. So straight away we've got there, it's got a number of faces on it, and obviously we can start doing a design. You can see at the top here there's a bit of puckering, and we'll probably see the same at the bottom, and this would be where we could have added in more feature lines to make that smoother and neater. So that's got us to a solid body very quickly from the mesh, but we can actually do this a slightly different way. So if we show the mesh again, what we can also do, as well as surface wizards, we've also got this curve wizard. So what I'm going to do is start the curve wizard, and with this mesh, and we've got a number of different creation methods for our curves. In this case we're going to use section. So it's going to create a number of planes through our mesh, and then it's going to create a number of sketches on those planes showing the different sections through our mesh. So in this case what I'm going to do is I'm going to select something on the top plane. Sorry, I've done that in the wrong order. What I'm going to do is I'm going to select the top plane because that's where we're going to pull from, and I'm going to select a point to start creating the planes from. Now this has gone up, so we want to pull the other way, and in this case I may have done this once or twice before. We're going to choose the number of planes to go through our model. Obviously the more planes you have, the more section curves you have, and the more detail you get out of it, but this should show us what we need for the moment. So I'm going to hit accept to that, and I now get a single 3D sketch with a number of section curves in it. Now I can use this to do a lofted surface or a standard SolidWorks lofted solid. So in this case what we do is we select our profiles, and each time we will get the selection manager up, because all of the 3D sketches are in the same place. We're trying to make sure this line of green dots goes in a relatively straight line, because then that will give us the best result from our loft. Occasionally it thinks I select the back. Those of you who do a lot of lofts will recognise that as standard practice. Now because I'm going quite quickly, I'm not worrying too much about how straight this line is, other than making sure they're in approximately the same place. Again, the more care you take, the better your result will be at the other end. So if I drag that one over there and then hit the tick, what we do now is we get another solid, which is a loft. Now obviously we've got a bit more control over this than the automatic surface, because we can start to change our sketches around. And if I select it, you can see how close I've got, seeing where things bleed through and where things don't. So you can see the edges are less good than the central section. Again, we get very quickly to a solid where we can start to use our standard SolidWorks functionality. So that is taking meshes, bringing them in, and getting them to the point where we can do something with them, because when they're just a mesh file, there's not a lot you can do. So now I'm going to move on to the direct editing side of things and look at the different functionality. Now, before I start, one question we often get asked is, what format should I get somebody to save something in, or should I save something in to send to somebody? Now, it's difficult. You can see here I've got a number of bike hubs. We've got an IGES file, a step file, and a parasolid file. I took a file that we'd received or that we downloaded, and I saved it, or imported it in SolidWorks, got it nice and finished, saved it out to each of those three formats, and then imported it in and see which was best. Now obviously it's going from SolidWorks and back to SolidWorks, and I could see no conceivable difference between them. But something we tend to recommend is, if you can get somebody to send you something in Parasolid, do so, because that's what SolidWorks is based on. The analogy I use is that you understand a Frenchman talking English better than you understand. You understand a Frenchman talking English badly better than you understand a Frenchman talking French well. And that's because he's speaking your base language, and Parasolid is SolidWorks' base language. So if you need a transfer format, Parasolid is probably the way to go. So I'm going to open that file, and we can run import diagnostics. I'm not going to cover import diagnostics in detail today, but just want to mention you've got faulty faces and faulty gaps occasionally on models. If you've only got sort of 3 or 4 in each box, click attempt to heal oil. If you've got, say, 15 to 20 in each box, attempt to heal oil will take a long time and you may not get a good result. So attempt to heal either faces or gaps using one of these buttons. If you're talking 40 to 50 in each box, or even more, then what I recommend is click around in the list until you see something that's quite a big fault, if that makes sense, and then attempt to heal just that one fault by right-clicking on it and choosing Fix. Because sometimes you'll find you'll fix one faulty face, and a whole number of gaps and other faces will be fixed automatically as part of the process, and it can be a way to cut the list down in sort of a manageable way. So I'm not going to go with feature recognition, we're going to move straight on with this. Now SolidWorks have a direct editing toolbar, and this is where all the most common tools are. A little while ago there was a big hoo-ha about another package brought out, a new tool, it's brilliant direct editing, and SolidWorks didn't really make a fuss because we've had a direct editing tools for years, so we just sort of reissued a whole load of videos as our counterpoint. So we're going to be using this toolbar. Now the first thing we're going to be doing is we're going to be breaking this model up, because we're going to be working with a slightly bigger wheel, so we need a wider hub, and also we've improved our brake disc, so we no longer need 6 fixings, we only need 5. So that's the other change we're going to be making to the model. So the first thing I need to do is get a plane that's roughly in the middle of our hub, so we'll drop that there, and then what I'm going to do is I'm going to use the split command using plane 1 to cut everything up. Now I get 4 results. The reason I get 4 results is because there's an inner and an outer at both ends, and I don't want to kill them off, and I do want to keep all of them. At this point don't worry too much about the tick boxes, but I'll explain why they're useful later, and we'll hit the tick. So now what happens is I have 4 solid bodies, an inner and an outer on both sides. So what I'm going to do is I'm going to choose to move them. The bodies I'm going to move are the ones on the left, and I'm going to choose to move them in Z by 10 mil, and that just shifts them out of the way. Don't copy them, just moving them. So I'm now left with a gap in the middle. What I can now do is I can use the move face command to take these 2 faces, and because it's 2015 I can choose faces from different bodies, and I can choose to offset that by 10 mil, so it brings them in line with the other ones again. So we're going to hit the tick there, and now what I can do is I can do a combine add. I need to do 2 of these features because otherwise what happens is I will join the inner and the outer together. So we'll combine the inner first, and then we'll combine the outer, So we now have two solid bodies again. So very quickly I've been able to increase the size of something in order to make it fit my purpose. Next we're going to have a look at our fixings on the end. So currently I've got 6 and I want 5. Well, the first thing I could do would be to start using the surface tools to close this hole up. So for example, I'd select this surface, I'd delete the face, take the one at the back as well and just delete it. I could then select the hole, press the delete key and just choose to delete the hole away, and then use the filled surface in order to fill this gap at the back. And if we choose a curvature across all of them, we actually get a very nice result. Choose to fix at the boundary, merge the result if we can, and hit the tick. And we'll get a very nice finish at the back there. But I'd have to do that for every single hole. So actually what I'm going to do is I'm going to choose to dispose of all of those, and instead come back to my direct editing and choose move face. And we're going to offset this face by 2 mm inwards. And the reason I'm doing that is what I want to do is get this hole outside the obvious cut radius, which is this arc here. Now that's both quicker, and I can do all of the holes in a single feature. Hit the tick and it's done. So now I can start splitting these up and cutting them away. So again, if I create a sketch on that surface, we can then create a circle from there out to our arc, and we can use our new circle as a cut. So I'm going to, first of all, I'm going to cut it. Now I've left all bodies selected as my target bodies to cut, so it can potentially cut both the inner and the outer. And what I want to do is I only want to cut off the bits that are relevant to me. So for example, I want to cut these 6 bodies. Now the reason I do that is it means this won't get cut and this won't get cut in order to leave me a whole load of bodies to add back together later. So I'm only cutting off the ones I want. Again, I don't want to consume my cut bodies. So now what happens is I've got a number of bodies which are separated off. At this point I've got no interest in these 5 here. I'm just going to pattern this one around so we can actually choose to delete those away. We can then do a circular pattern. Oh, help if I was in the right box. We need to pattern bodies, and then straight away we've got our 5 there. So we'll let those pattern round. We then need to do a combine again, which is everything else because I didn't cut it, plus our 5 new bodies. And finally we need to make our holes the right size again. So again, it's a single move face command. This time we want to offset outwards. And hit the tick. Oh, it'd help if I actually hit the tick. So very quickly, I've added my, I'll change my hub diameter, or width I should say, and change the number of fixing holes. And I've done all of this without having anything more than a couple of imported bodies. So it's very easy to do. Right, now we're going to have a look at some other of the direct editing tools, some slightly more complicated ones. And this is a step file this time I'm opening. I'm not interested in import diagnostics because I know it's alright, and feature recognition I'm not going to be looking at either. So I've got 2 of these brackets. Those of you who did the simulation course a bit earlier may recognise them. The first thing I'm going to do is hide one of them away. Now what we want to do with this bracket is beef up the amount of material around this side. You may have seen it, we've got a little bit iffy in the simulation, and also we want to flatten the model out, so we want to bring this side down. So to do that, first of all I'm going to start deleting a number of faces in order to clear up, and I'm also going to put edges on so that I can see them. So delete face, and we're going to select the face, and we're also going to select all surrounding faces. So again, using a selection manager to speed up the rate at which I can get hold of stuff. and we're going to choose to delete and patch. And that just gets rid of our hole there completely. So next what I'm going to do is we're going to change this outer shape. So I'm going to sketch on this face, and I'm going to go normal to it. And what I'm going to be doing is very rough. And then we'll just adjust that so that it looks about right, so about there-ish. So this is where we're going to be moving it around. And what we're going to be doing is we're using this sketch in order to stretch this face to that new position. Now I'm also going to create a matching sketch on the reverse face. The reason for that is it enables me to control both the back face and the front face at the same time. And we'll choose exit sketch. And then what we're going to use is we're going to use the deform feature. And we're going to use the curve to curve. So we're essentially going to take the outside curve and shift it to the far side. So which curves are we going to be affecting? We're going to be taking the original one. Now it does actually matter which selection set is in which box, because it's the curve you're moving from to the curve you're moving to. So first of all I'm going to select the model edges, and then I'm going to select, if it will let me, as the first selection set, and then the second selection set I'm actually just going to select the whole sketch. And then for set 2 we're going to do exactly the same selection. But on the other side of the model. Of course, if I listen to my own advice, I'd remember to click in the right box. So now you can see how it's going to bend, and you can see there's a whole load of stuff going a bit wibbly. So what we're going to do is we're going to choose to fix some faces. Now obviously these holes are going to have bearings in, so we want to fix these holes so they don't change shape. And as you can see, as I click around, you can see it's not, it's straight away the shape is changing. I also want to select these outer faces as being held in place. You can see how my shape here is changing, and you can choose how stiff the material is that you're moving can affect that shape. So we're gonna take it in the middle. We can then choose to how accurate our shape's going to be, and this is how accurate the moving items or the fixed items are going to be. In this case, I want to make sure my fixed items stay very accurate. And then there's a sort of weight over whether the fixed items have more weight or whether the moving items have more weight. You can see that my holes here are not going to be the correct shape afterwards. So you're just going to be a little bit careful of that. You could spend a little bit more time getting a nicer finish, but you're unlikely to ever get those holes perfect, and you can't choose to fix them because of course they need to move. So we're going to accept that. And obviously, like I say, you can play with those a bit more, and even if they came out and they were very nearly circular, you'd probably almost certainly see two faces here, which would be the giveaway that they are no longer circles. So we need to delete and recreate those based on the new center of that arc. This face here is still planar, so we can still sketch on it. So although it's deformed it, this is still planar, so we can sketch on. Now obviously our new model is a little bit weighty in comparison, so what we're going to do is we're going to put a new feature on here. So I'm going to create a sketch, and then I'm going to create a straight slot. Just give me a second to dimension this up. And then I'm just going to do a very simple cut. I need to be careful just to go up to next, because otherwise I could potentially cut the body in the background. Remember, although I've hidden it. And then I'm going to pattern that down this edge. 22, so we get them all in. And then we're also going to vary that pattern, both the 5mm and the 15mm. The 5mm I want to vary, and I'm going to increment that by 20. So the idea is that my slots are going to get 20mm bigger each time. The 15mm I'm not actually going to explicitly vary, but I will need that shown because I want to modify this instance, because I don't want it to clash with the hole, and we need to make sure it's not too long. And then we can hit the tick. So very quickly we can use our new linear pattern and vary functionality in order to get that through. Then finally, if I re-show the imported body, we can see the change in shape. So here's the original one and how we've dragged it down and redone the pattern. Thank you very much for watching.